Good day. This is Group 2's presentation on the design of the heating, ventilation, and air conditioning system for the 17th floor of the BIR Tower, Government Plaza, Richmond Street. My name is Rihanna Kanhai, and I will begin our presentation with an introduction. Introduction. The Elite Shiva computer software was used to determine the cooling load necessary for the assigned building. Methods for calculating the cooling loads used were developed by ASHRAE, and these are cooling load temperature difference, or CLTD, and radiant time series, or RTS. The aim of this project was to design the ventilation and air conditioning system for the 17th floor of the Board of Inland Revenue BIR Tower. To successfully complete this study, objectives were outlined as shown here. This involved data acquisition from research and floor plans, input of said data into the Shivak software to obtain the necessary cooling loads, and finally, the creation of the required air distribution system. The scope of the project entailed the use of the Shivak software for cooling load calculations and the sizing of the duct system as detailed here.
My name is Kevin Ramkilawan and I will continue with the methodology of the project. Based on the scope of work, a detailed methodology was constructed which would allow for successful achievement of all objectives. Literature review. To gain a better understanding and properly conduct the study, necessary research had to be done. Research was done on HVAC equipment, types of cooling loads, ASHRAE standards, and the use of the CHVAC software. To gain a better understanding and properly conduct the study, necessary research had to be done. Research was done on HVAC equipment, types of cooling loads, ASHRAE standards, and the use of the CHVAC software. Design specifications were predetermined to perform calculations and to enter data into the CHVAC software in order to get the required results. The floor plan was used to identify and group rooms which needed to be ventilated and those that do not. Figure 1 shows the floor plan of the 17th floor in the BIR Tower, with all rooms requiring ventilation as well as rooms not requiring ventilation.
My name is Carlos Mike and I will begin by discussing the operating profiles. Since this is an office building with limited daily working hours, the HVAC system will not need to be at full operating capacity 24 hours a day. The building will have different levels of usage with respect to occupancy, lighting, and equipment during standard working times, 8 a.m. to 4 p.m. Monday to Friday, a few hours before standard working time, and during the night. Operating profiles were therefore selected which were assumed to be adequate during these different periods of the day. Temperature. The CHVAC database and the Piaco International Airport were used to obtain the indoor and outdoor conditions. These conditions vary throughout the year on a monthly basis. Calculations. U factor. U factor is a measure of the ability of particular building structures to insulate the inside of the building from outside heat conditions. U factors were selected for external walls, glazing, glass windows, and partitions from the CHVAC software. Room dimensioning. Dimensions for the width and length of each room were obtained from the floor plan, and the floor to ceiling height was assumed to be 3 meters. The area for each room was calculated by multiplying its length by its width. Occupancy. Sensible heat load and latent heat load are two types of heat loads which people emit. The average occupancy per room had to be taken into account, and the associated heating loads had to be included in the design calculations.
My name is Ramiz Gultran and I will discuss the equipment and lighting. These are both heat sources which add to the total heat gain of the room, therefore, their effects had to be accounted for in the design calculations. Equipment has chosen based on the various rooms in which they are stationed. Lighting was determined from the provided lighting layout diagram. Infiltration and ventilation. Accidental and unwanted infiltrated air from the outside consists of a combination of sensible and latent heat, and therefore must be accounted for and removed from the building. Results. The ventilation rates and the total loads of the entire 17th floor of the BIR building was obtained from the CHVAC software. The total load and the total coolant supply airflow results are based on the CLTD and the RTS methods are listed here. Results from the CLTD method was used for the rest of the study due to it producing of higher values. Table 1 shows the sensible and the latent loads and room air supply for each room using the CLTD and the RTS methods on the CHVAC software.
Good day, my name is Andrew Sinat, and I will present the dock sizing section of the project. Dock geometry and sizing. Round docks have many advantages over rectangular docks. For instance, they have better rigidity and lower pressure docks. Thus, round docks are used. The equal pressure drop method was used to size the docks, with an average pressure drop of 0.6 pascals per meter. The pressure loss for the T-joints and straight docks are found first to obtain the overall pressure loss. The proposed layout of the dock system is shown here. This is a summarized pressure drop table showing fittings, dock, total, and commutative pressure loss. The total pressure loss for each dock, branch, and its T-joint was found. Then the commutative pressure loss was determined with the final pressure loss of 243 pascals.
My name is Hemawati Sudama and I will continue on dampers and fan sizing. The damper pressure required for each room branch was determined and a fan was selected. A fan with an airflow rate of 5,189 liters per second and static pressure of 243 pascals is required to properly ventilate the building. Using the centrifugal fan performance curve, a centrifugal fan with 500 mm diameter and 930 rpm is selected. Discussion. The key points of the discussion are as follows. U factors, room dimensions, occupancy, equipment, lighting, infiltration, and ventilation were calculated to input into the CHVAC software. The total air supply rate needed was determined using CLTD and RTS methods. The results from the CLTD method were used since the air supply rate was higher. The duct system was sized using equal pressure drop procedure. Fan sizing was done using the branch with the greatest pressure drop. Conclusion. To summarize, the HVAC system was successfully designed for the 17th floor of the BIR Tower in Port of Spain, Trinidad. It can be said that the initially set out objectives were achieved successfully. This brings us to the end of our presentation. Thank you for your undivided attention.